Okay, Unit 4, Day 7, actually the last day of any new material for Unit 4. So after today, you should be prepared to go ahead and try that PFA. Just make sure you have all the formula type things that I've given you for this unit written down somewhere so you can use them. Okay, so we're going to solve this log equation just as a little warm up. So I need to isolate my logarithm. I also can see that I need to bring this 6 out front. So I'm going to do all that at the same time. So I'm going to have negative 6 log base 5 of 4x minus 11. If I subtract 3 from both sides, I get negative 6. Also, I need to think about my domain for my argument. If I set that in my head greater than or equal to 0, x has to be greater than 11 over 4. Add 11, divide by 4. So now I can divide both sides by negative 6. I get log base 5 of 4x minus 11 equals 1. Change to exponential now that I have that log isolated. I'm going to add 11, so 5 plus 11 is 16. If I divide both sides by 4, I get x equals 4. And 4 is greater than 11/4, so that should work just fine. Okay, so we're going to do a few more applications. These get just a little bit different than what we did yesterday. They actually get a little bit more involved. So make sure you write everything down, and if you need to stop and pause and think about what you just wrote down, that would be just perfect. Okay, so this one we're trying to figure out how many times more intense is an earthquake that registers 7.1 than an earthquake that registers 6.3. Okay, so my I, or my quake number 1, we'll call that the stronger one at 7.1. And quake number 2 is 6.3. Okay, so on this problem, what I need to do is I need to find the difference in those magnitudes. So I need to subtract my two intensities and get 0.8. So that is the difference of intensities. Which is going to be helpful in finding how many times more intense that first earthquake is. Okay, so one thing we need to think about as well is that I over I sub 0 that I talked about yesterday. So remember, that's the stronger quake over the weaker quake. So that is called my ratio of intensities. Basically, what I'm looking for is that ratio. How many times more intense? Okay, so I'm going to take the formula that I gave you yesterday for the log, for the earthquakes. So I have log. I don't know the intensities of those quakes. I just know the magnitudes. So I'm going to keep my I over I sub 0 since that's my ratio. And I need to take that and I need to set it equal to the difference in those two ratios, which is 0.8. So now I have that logarithm set up. And all I'm doing here is I'm solving for I over I sub 0. So I have 10 to the power of 0.8 equals that argument I over I sub 0. So if I go ahead and take my calculator and take 10 to the 0.8 power, I get that ratio of 6.31. So that is my ratio of intensities. So that is what this problem is asking for, is that 6.31. So quake number 1 is 6.31 times more intense than quake number 2. So the Richter rating is not necessarily intensity. It's just the magnitude or the strength of that earthquake. So that's why these get a little bit more complicated. You got to think a little bit farther outside the box. Okay, so now we'll do a decibel one. So a motorcycle is 95 decibels and a lawnmower is 65 decibels. How many times more intense is the sound of the motorcycle than the sound of the lawnmower? So basically the exact same method, a little different formula because it's decibels that I did on the previous problem. So I'm going to call my motorcycle. I've got to find the difference in those decibel levels, which is going to be 30. So that gives me the decibel levels. Now I need to calculate the intensity level between those two objects. So if I write my formula for decibels, I've got 10 log. And remember, my intensity ratio is the stronger one over the weaker one. So I'm going to do the intensity of the motorcycle with a little sub m over the intensity of the lawnmower. And I set that equal to my 30. Just like I did yesterday for the difference in those Richter ratings. So now I can solve for my intensity ratio. I sub m over I sub l. 30 divided by 10 is 3. So if I take 10 to the third power, I get that intensity level ratio. So that's 1,000, right? 10 to the third power. So the motorcycle is 1,000 times more intense than the lawnmower. So we all know that motorcycles typically would be much louder than a lawnmower. Okay, a couple more, I think. Okay, so here I'm giving you the intensity level. The ratio of that is 63 times more intense. Okay, so it's the blender has 60 decibels and is 63 times more intense than a phone ringing on high. How many decibels is the phone ringing? So I'm giving you some different information. So it says the blender is more intense than the phone. So if I do I sub B as the blender and I sub P as the phone, then I can use this idea, kind of like I did yesterday, and I can set up an equation that's going to help me with my ratio that I have to use for my logarithm. So if I take my phone and multiply it by 63, I get my blender. So I sub B, or the blender, is equal to 63 times I sub P, because remember the phone is weaker than the blender. So this is a decibel one. So all I'm doing is substituting numbers in here now. So I have 10 log. Okay, so remember the blender's more intense than the phone. So I have 10 log. If I do a substitution for the blender, I get 63 I sub p over I sub p. So now they're both in terms of the phone. So my I sub p's cancel. And I just have my 63 in here. So if I do 10 log 63, I get 18. So remember, that's the difference. Like I did on the previous examples, I just calculated the difference between the decibel levels. So I know my blender minus 18 is equal to my phone. So just a little bit of a twist on what we did in the last two examples. The last two examples, I was able to calculate this subtraction. So my blender is 60 minus the 18 is going to give me my phone, which is 42. So just a twist on what we did in the first two previous examples. You just really got to understand what you're pulling out of these problems and what you're trying to calculate. Okay, so one more. Earthquake 1 is 5.0 and is 141,000 times less intense than earthquake 2. So earthquake 2 is the stronger one. Earthquake 1 is the weaker one. Okay, so quake 1 is going to be my I, since it's the stronger one. I'm sorry, quake number 2. Quake number 1 is my I sub 0, because it's the weaker one. So now if I go back and use this 141,000 times less, then I know if I take quake number 1, multiply it by 141,000, I get the stronger one, which is quake number 2. So I is equal to 141,000 times I sub 0. Weaker quake times the ratio is equal to the stronger quake. So now I can go in and calculate what I need for the Richter rating for quake number 2. So I get M is equal to log. Okay, so remember it's I over I sub 0. And I've done this a few times, so I can go ahead and instead of writing I can just write my 141,000 I sub 0 over I sub 0. So I get log 141,000, which is about 5.15. So now remember, quake 1 is my weaker one. So quake number 1 plus the difference I just calculated, 5.15, is equal to quake number 2. So quake number 1 was 5. So that's going to be a 10.15 rating. If you go back to the chart that we looked at yesterday, that's a pretty strong earthquake. Lots of damage is going to happen with that one. Okay, so There are those problems with decibels and earthquakes. And we are at the end of the unit. I think I have just a couple review problems for the next day, and then I can assign the project. So hopefully you're working on these assignments. Remember, you need to be ready to turn those in all at the same time. You should be grading them. I posted all the solutions on the Summit document at the bottom of each page for the current unit. And I believe in class, I will have mentioned a few times by now that for the review has, I think, about 30 problems on it, which is a lot. So I want you to choose to do either the evens or the odds, but don't do both unless you're really, really, really enjoying this unit. Have a great day.